All right, we are going to get number 48 done on page 269. This is the one we started in class, but let me go over it and then let's see if we can make this easier for everybody. So I start here. This is my problem right here, and then this is what I'm going to use. This is from our page, from our example 5, but it is from page 265, the definition of the area. And so I wanted to go over what the pieces were. So this delta x is going to be b minus a divided by n. And then the c right here, the c sub I, is going to be a plus delta x I. And delta x, we know, is this b minus a over n. And so the a is going to be what our bounds are. And in this case, our bounds are x equals 2 to x equals 5. So those are our two bounds. So a is 2 and b is 5. So I know that delta x in this case is going to be 3, right? 5 minus 2, 3 over n. So that means that's going to get plugged in here. I is our counter, so we're not replacing that, but I can replace a with 2. So c sub I is going to be 2 plus 3i over n. I'm going to put parentheses in it because we're going to plug that in up here. All right, so we know this is going to be the limit. I'm not going to rewrite that every time, so I'm going to kind of just leave that in my margin over here. So this is the limit as n goes to infinity, and we'll see that again at the end. And then we have our summation, I equals 1 to n. And then we have our function evaluated at 2 plus 3i over n. And where this comes from, this value for c sub I, is from when we find the areas using the maximum in that area. So we use the right hand side of the rectangle. And so that's always going to be equal to whatever the a is plus how many iterations we've gone through the summation. And so the first time through, it's just going to be how many times we've split this area of 3, this length of 3, how many pieces we've split it in times 1. And then the second time through, it would be just 2 of those. So let's say we split it into 100 pieces, it would be 3 hundredths. If we split it the next time through, it would be 6 hundredths, etc. So that's kind of how we use this. And then this is my height of my rectangle, and so my width is my delta x right here, and so that is going to be times 3 over n. And so we've got everything set up. Now we just need to go through our process. And then I have, on this paper, I would recommend you do that on a card or something. You have all of these ready to go, so they're ready to plug in. Okay, so this was what we wrote down the day before. And it's on page 263, somewhere around there, I think 263. All right, so I have this right now, and so my function itself is 3x minus 4, so I'm going to put that in now. And so I have my summation, and I'm not going to rewrite the counting part, but I'm going to go, okay, it's 3 times 2 plus 3i over n, right? That's going to be kind of like my x, right? I'm evaluating it at, and then I minus the 4, but I'm going to multiply that again. So I'm going to put square brackets around it, and then 3 over n. And then I am going to go ahead and distribute what I get in here. So I get 6 plus 9i over n. and then that is minus 4. This is still in the square brackets, 3 over n. I'm going to combine like terms here, so I get 2. So again, I'm going to rewrite. So you could do this in one step, but I want to make sure we're seeing what we're doing. You can just do all the algebra over here, the simplification. So I get 2, not really algebra, just simplifying, plus 9i over n times 3 over n. And now I'm just going to split this up. So I'm going to turn this into 2 of these summations. So I'm going to bring the 3n out, 3 over n here, and then that is going to be the summation of 2 plus 3n, right? Kind of like the distributive property, summation 9i over n, like that. Okay, and then I know with my rule that C is just going to become C times n. So this is going to become 2n. So that gets rid of my summation. So I'm going to write it out. So 3 over n, and then this is going to become 2 times n, so times 2n, plus 3 over n. And now I'm going to look, this is going to be a little bit more work. So I'm going to do this in a couple steps. But I can go ahead and bring out this constant 9 over n and bring it out. So 9 over n summation I. Okay, so I'm going to rewrite one more time. So on this one, the n's will cancel, so I just get 6. And then I have plus, over here, I have 27 over n squared. And then I have my summation. And then I want to get rid of that summation. So I'm going to just put parentheses here. And what do I get for the summation of I? So the summation of I, as I go through this, is going to be n times n plus 1 over 2. But I also know it's this right here. So if I multiply it out, I'm just going to get this. So I might as well just do this piece here. And so I'm going to get n squared plus n over 2. And so I'm going to go n squared plus n. And then this is over 2. So I'm just going to make it where each of them is over 2, just so that I can go ahead and distribute this outside term. So now I have no more summation. This is still in this limit, right? This is still my limit as n goes to infinity right here. Okay, so I haven't gotten rid of that yet. So I'm going to rewrite what I have. I have 6, and then I'm going to go ahead and distribute this right here. And so I'm going to go plus. Now the 27, nothing really happens with that. So I'm going to go 27. Now the divided by n squared is going to cancel with this. So I'm going to get 27 over 2. Then I'm going to distribute it to this next piece, 27. The 2 really won't cancel with it, but the n will cancel one of these n's. So I have plus 27 over 2n. And then I'm doing this as the limit of n approaches infinity. So I can combine these two things. They are like terms, right? They're both constants. So I can make this 12 halves. And so now I can add those together. So I get 39 halves plus 27 over 2n. And the limit as n goes to infinity. But as n goes to infinity, this right here is going to turn into 0, right? It's going to be 27 over infinity to infinity and beyond. And so I just get, I'm left with this. 39 halves is my area. So good problem. I'm going to do another one, but I want you to try to do it by yourself. So I'm going to pose the problem and then pause it and then see if you can do this, or you